Good morning, everyone. Hope y'all's having a good day. Our day just started here. Still dark out. So what we have here is a Unitek Servo drive, model number TVD 6.2-400-10RS. And the complaint with this servo drive is that it won't power up. Now I've already taken my meter and tested UV and W against bus plus and bus ground. There's no short circuits on the power device. I have a variac, a voltage doubler attached to plus bus and bus ground input to the drive. And let me turn this light on here. And we're going to bring the DC bus up slowly, and somewhere around 170 volts DC, this drive should power up. And I usually take it up to 300 volts DC, so we're going to do that and see if that power supply will come up. I've got the mirror looking at the LEDs on the front of the drive, and when the switch mode power supply comes up, some of those LEDs should turn on. We'll see. Can you all see that meter? Well, right now we got 641 millivolts. Let's turn on the variac. Okay, we're up to 72.5 volts DC. We'll slowly bring that DC bus up by rotating and increasing the AC from the variac to the voltage doubler. There's 198 volts, 203 volts DC. I don't see any LEDs. 250, 262, 267, 270 volts DC, 272, almost at 300. That power supply should have came up a long time ago. We're going to have to go into this drive and find out what the problem is with that switch mode power supply. We're 312 volts DC right there. Okay. Let's turn the variac off and unplug it from the wall. We're going to let that DC bus voltage come down before we go in. We don't want to get ourselves lit up today. We're going to let that DC bus come down. Alright, we're disconnected from the voltage doubler after the DC bus dropped to 0 volts DC. Now what we have to do is get inside. Now there's screws underneath this pull handle right here, so I need to knock that front plate off so we can get to those screws. We have to take the front panel completely off to remove the control board because there's a stake connector right here, and then there's a test point connector right here, and because of that we can't lift the control board off of the power board until we get that front plate off. So let's knock our cover plate off. There we go. Okay, we got that removed. Now, take these two screws off. And that'll remove the pull handle. The servo drive mounts into a backplane, and the backplane has the control signal input connectors, the power connectors to bring the line in through a bridge rectifier on that backplane. The backplane allows this drive to mate to the machine. There we go. Now we take these screws off there. They have nuts on the other side And then we take these two screws off right here, and we'll be able to remove that front plate. A little Phillips screwdriver. Sometimes these are common screws. Sometimes they're Phillips. In our case, we have all Phillips, except for the two holding the front plate to the, uh-oh, put that screwdriver down, to the heat sink assembly. Put the nuts on the screws so I know where they came from. I keep dropping that. Come on, left hand. Come on, we're at work. Do some work, left hand. Better talk to my left hand to get it going. Still a little bit weak on that side. It's coming around. Some days it's just not there. Okay. I used to be able to do that without thinking. Come on. There we go. Okay. Now we have those 4 screws and nuts removed. We'll take these 2 screws off, and that front plate will come off the drive. All right. Now these 2 screws we'll remove from their standoffs, and then we can lift the control board off of the power board. Separate the stake connectors. Here we go. Here's the stake connector that routes the power supply from the switch mode power supply up to the control board and sends the firing signals from the control board down to the power board. Also the enable signals and whatnot. So we'll set these things off to the side, because we're not worried about that right now. We want to get in here. So in order to separate the power board, you have to remove these 2 standoffs right here. Okay, now there's stake pins, little stake connectors that come up from, well, I'll show you in a sec, but they mate the power board firing channels to the board that sits on top of the IGBT. So we just have to like gently bring that up. Oh, let's see. Oh yeah, I forgot about the thermal. Let me go ahead and cut the thermal wires. I can solder them back together, but the easiest way to undo these is just to clip them right here in the middle. There we go. It's no problem. We solder that back together when we get it apart. When we get it back together after our repair. So here is the IGBT. And this board right here, you have your bus capacitors. There's other circuitry down in here, resistors and diodes. And here are the little stake connectors. They're 3-pin that mate the firing channel to the bus capacitor board that's on top of the IGBT. It routes the firing signal, gate emitter firing signals, down to the IGBT. So I take those off because I don't want to poke myself. Okay. Now, we're going to get closer. But right here is the DC bus input. And there's a forward bias diode, comes off a plus bus, goes through a 470 ohm resistor over to the switch mode power supply. And the switch mode power supply is this circuitry right here. I've got it drawn out, but let's get closer to this circuit right here and to this one right here, and we'll look at these items with our meter. Very first thing I do on these drives when I have a power supply problem, I'll check this diode and check the 470 ohm resistor. These are open. If this resistor is open, that switch mode power supply is not going to come up. But usually, if it opens up, it's because there's a short circuit in that switch mode power supply. So after you replace the parts, the shorted parts in the switcher, and it still don't come up, it's because of this resistor. So let's check the diode. Okay, the diode is good. Let's set our meter from diode test mode to ohms mode, and we'll check this resistor. Okay, yes, it's opened up. We have OL in the meter instead of 470 ohms. That resistor's opened up. So we're going to have to replace that resistor. But before we do that, let's go over and find the bad parts in the switch mode power supply circuit. Here's our power supply section. And we're going to go through. I'm going to try and get down between my meter. I wish I could move this a little bit out of the way, but I'd like you to see what we're looking at. Here's our switch mode power supply IC. Its part number is UC3843B. And pin 5 is ground. So we're going to put our red lead on ground. I've got to figure out how to get around my meter. And we're going to go and probe around the other pins with our black lead. There's pin 1, 0.639 volt diode drop, 0.695 on pin 2, 0.101 on pin 3, that's normal for this type of power supply circuit, 0.641 on pin 4. Let's come around to the other side. Red lead again on pin 5. Let's see if I can get in here. There we go. Okay, black lead on pin 6. There's 0.266. That's good. There's a fast recovery diode from pin 6 to pin 5. Cathode on pin 6, and that's what we're seeing. Okay, there's pin 7, 0.577, that's good. Pin 8, 0.567, that's good. Now normally, we'll see that IC shorted, but there's no short circuits on that IC. Let's go around here. Here, I'll show you that fast recovery diode, pin 6 cathode, pin 5 anode, 0.266. That's good right there. Let's go up here and check the switching MOSFET. Now, I'll put my drawings of this circuit up at the end of the video. If I can get around this way. I'm trying to get in here without getting in front of the oscilloscope. I mean, in front of my meter. Okay, red lead on the gate, black lead on the drain. That's good, not shorted. Black lead on the source, 2.985. Okay. Now I'm moving the red lead to the drain, black lead to the source. Oh well, that's not shorted. Huh. So far so good. Now let's go up here to this circuit. We'll check this Zener diode. 0.402. Okay. Now we're going to go into resistance mode and start checking some resistors. Here's some 120 kilo ohm resistors. Looks like they're not opened up. There's 91.1 kilo ohms. Here's another one. Okay, it's not opened up. 91.3 kilo ohms. Not quite 120, but not open either. Let's go down here. We'll check these resistors. They come from pin 6, the output of the PWM IC, the switch mode power supply IC, and go to the gate of the switching MOSFET. There's our 10 ohms. That's between pin 6 and the gate. Here's a 22 kilo ohm resistor. Okay, that's good. 21.79 kilo ohms. That's good. Well, I don't see anything bad. What I'm going to do is I'm going to replace this capacitor right here and replace that 470 ohm resistor. We'll power it up again and see what happens. Normally what I see is the switching MOSFET will be shorted and the UC3843 will have shorts on the output pins, but not this time. Well, maybe we lucked out. Every now and then I get thrown a bone, but we'll see this time. they bend the leads over on their resistor here. It makes it really a little bit tough to get out. So I use my pair of side cutters there. And it makes it a little bit easier. Okay, we got the old resistor removed. Here's our new resistor. Push it up a little bit from the back side there. Looks good right there. Solder the other side. Now we'll replace that 47 microfarad 25 volt capacitor over here in the switch mode power supply circuit. Let's see which one it is. Okay, it's those two right there. They bend the leads over on that too. Okay, I'm going to add a little bit of solder to help the old solder flow. We'll see if I can straighten up the leads. It will rock the capacitor out. Heat up one side, rock the capacitor out. If I can, get these leads straightened up. I think I got it. Not much room in here. Still a little bit bent over. Let's see if I can cut the leads off. I don't know if that helped. It's like pulling teeth. Let's see if we can do it the old-fashioned way. Okay, it's loose. There, it's out. Okay. capacitor. Let's install the new capacitor. Holding the capacitor with my ring finger. There we go. Okay. I'll clean the board up and we'll put it back together and see what happens. Now for the fun part, the part I dread. We have to align these stake connectors between the two boards. It always takes me 1 or 2 tries to get it right. So what I do is I'll install the stake connectors onto the IGBT bus capacitor board. Then I'll lay the heat sink up against my chest while I look down into the assembly and try to line up these white connectors here with the stake connectors on the IGBT bus capacitor board. Here we go. This always takes me a couple of different tries to get it right. You're not going to be able to see what I'm doing. Let me move the tripod a little bit over this way. You're not going to be able to see down inside, but you'll get to hear me cuss every now and then. I got to get my close-up glasses on. Okay, here we go. Okay, come on. Kind of dark down in there. Hard to see. Okay, there's the back side. Is that everybody? Now you know you've got it right. You can see that they poke up through the power board. Okay, everybody's in. That's the first time I ever got it on the first try. Unbelievable. Hurry up, bolt that board down before they pop out. Okay, something's not right here. That's never happened before. It always takes me about 5 or 10 tries. Okay. There's the standoffs. I can put the control board on. We're not going to put the front plate on or wire up the thermals until we see that power supply come up. Now we have to align this stake connector with its mating connector on the power board. There we go. Okay. Okay. Now we try it again. Let me bring the variac and the voltage doubler over, and we'll see if we've brought it back to life. There we go. With our variac and voltage doubler. Plug the voltage doubler into the variac. Okay. Don't hook it up wrong. Okay. 2, 3, 4. There's bus ground. 1, 2, 3, 4, 5. There's bus plus. Okay, let's put the mirror in front. Y'all see that? Not sure if you can see that. Clip the leads to hook up our DC bus to the digital multimeter so we can monitor what voltage we're at. Okay, I'm going to plug the variac into the power strip. Just turn it all the way down. All right, we're powered up. Straight. I got a bad clip lead. Oh, I'm in AC. There we go. Have to push the select button to get into DC mode. All right, 78.9 volts DC. We're going to go up slowly. There's 112. 168. We still haven't come up. Should have come up by now. Still a problem. All right, powering down. We've got to go back in. Well, we're going back in to find out why that switch mode power supply is not coming up. Okay. I might just change out this UC 3843 and be done with it. But it doesn't appear to be bad. I wonder if there's a way I could power it up just on the board by itself. Tack some wires onto VCC and ground to that switch mode power supply and see if it comes up from an external power supply. If I could do that. And try it. Let me go find some wires I can solder onto that IC. Right here's the UC38, and we're going to tack on to pins 5 ground, 7 VCC. But instead of soldering right onto the IC, which I really can't get to, we're going to go to the back side of this capacitor right here. It's also across pins 7 and 8. Going to tin our stripped wires. Right. Here's our capacitor we're going to solder onto. Add a little bit of solder to the pads. Gotta get my close up glasses. Turn this back a little bit more. That'll be pin 7, VCC. Trim this back just a hair. That will be pin 5, ground. flip everybody back over. Okay, we'll hook this up to the external power supply over there. We'll gradually increase the voltage until that switch mode power supply IC powers up. If it powers up. We'll see. Okay. Let's double check, make sure our red wire is going to pin 7 and our black wire is going to pin 5. Okay, red wire 7. Black wire to ground, pin 5. Okay. Now, there's a parameter on these power supplies. Let's see, put my glasses on. And the parameter is called under voltage lockout. Here's the data sheet for the UC 3843, the 42, 43, 44, and 45. There's pinouts. Right down here, under voltage lockout. The startup threshold, the start threshold for the UC 3843 and the UC 3845, the minimum is 7.8 volts, typically 8.4 volts, and max 9 volts. So we'll get just a hair under 9 volts. We'll use that top oscilloscope since it has a nice display. All right, okay, I got it set to 0 volts right there. Now we're going to take this oscilloscope, let me go ahead and power it up. And we're going to look at a couple of pins on that IC. We're going to look at, it's too small to read, it looks like RC. Let me get this picture back up here. We're going to look at R/C1 on pin 4. And if we see a sawtooth on that pin, it's running. We're also going to look at VREF. That's 5 volts out. There will be no 5 volts out if it's not running. Once it starts up and running, we'll have 5 volts. And maybe we'll even see an output on pin 6. Maybe. But if we see any activity on that IC, I'm going to have to suspect that it's not being powered up. Okay, let's get all hooked up here. There's ground of the power supply to ground of the UC 3843. Here's the positive output of the power supply to VCC of the UC 3843. Now we're going to apply the oscilloscope ground to this point right here. And we'll probe around on those different pins and see what we can find. Let's get close to that oscilloscope and I'll tell you what pin we're on while we're looking at things. Okay, we're going to start out looking at pin 4 as I gradually increase the voltage across pin 7 and pin 5, VCC and ground. There's 1, there's 3 volts, 4 volts, 5.5, 6.3, 7.4, there's 8.1 volts. Hey, look at that, 8.8 volts, almost 9 volts. And there's our sawtooth for R/C1. Now let's go look at pin 5, which is VREF. There we are. Now I've got the scope set to 2 volts per division, and that's 5 volts right there. That's our reference voltage, VREF. Pin 8, I'm sorry. Did I say pin 5? Yeah, pin 8 is VREF. Let's go look at the output. Pin 6. Look, it's actually switching. Let me change the amplitude. There's 5 volts per division. Look at that. It is actually running. There's nothing wrong with that IC. So we have to go back into the circuit and find out why that UC 3843 is not being turned on. I've just powered the external power supply down. This is interesting. Wonder what's holding us out. Here's my hand drawing of VCC and ground. That's an odd looking circuit. Here's the diode. Let me back up a little bit. Here's our plus bus and our bus ground. Here's the diode and the 470 ohm resistor that opened up. And we tested that diode good, and we replaced that 470. And it would not start up. The switch mode power supply did not start up. There's no shorts or on the control board to pull this power supply down. Over here is the capacitor that we tacked onto so that we could power up that UC3843. From the 470 ohm resistor, we have 2 120K ohm resistors, and we put our meter across that, and then both measured 80K and thereabouts, not open. Then we have this pass transistor right here, and it's set up by this circuit down here. Usually what you would see is a Zener diode right here, but they have another NPN transistor biased with these 2 10 kilo ohm resistors. And that regulates the voltage into pin 7. Now these 2 transistors, they measure good with my meter in diode test mode. The 10Ks, they measure good. Now this is a little strange right here. I don't understand this circuit, but we have a Zener, a 10K going into the gate of this MOSFET, or I'm sorry, going to the source of this MOSFET, and up here on the cathode of the Zener, that goes to the gate. And the drain comes back over here to this point right here, the other side of the 470. The Zener diode is good, the 10K ohm is good, the MOSFET's not shorted. So we got a lot to look at. And it's all compacted into that little 3x3 square, if not less. So I first want to look at these guys right here. I'm going to take them off the board and make sure they measure 120K. Right here in the corner of the circuit are the 2 120 kilo ohm resistors. We measured them as 80K, but I'm going to pull them off the board and see what they measure like out of the circuit. is loose. It's just a matter of getting these pins straightened out. Flip ourselves back over. All right, I got the right ones that time. One. Don't give you much room to get down in here. I wonder how the poor folks at the factory inserted all these resistors. Still got some bend to the lead. Push that through and straighten it out. It fell out. Good. It fell out. Okay. Let's move the drive out of the way and we'll bring our meter in. We'll see what they measure like. I hope they're bad. Okay, here's one. Look at that. 50.49 meg, 48 meg. Oh, sheep fire. That 120 kilo ohm resistor is bad. Let's see what this one measures like. Okay, that one survived. 122.8 kilo ohms. I'm going to replace both of them. Maybe that'll fix our problem. We shall see after I change out these two resistors for new. We'll put it back together and try it again. Here's our two new 120 kilo ohm resistors that we're going to install. Now, let me double check, make sure they're 120K. Way in the frame. I can't see up there. Okay. Stop moving around. 120.9 kilo ohms. Stop moving around. 121.2 kilo ohms. We got two good resistors that we're going to install. I'm left-handed trying to get into a right-handed circuit. Come on. Okay, there we go. There we go. Let's get that one first. There's the second one. Let's go ahead and measure them now, see what we get. Interesting. It's 88 ohms. Or 88 kilo ohms. And there's 89 kilo ohms. Huh, interesting. There's something parallel to that. Okay, we know we got two good resistors. One of them measured up there around 50 mega ohms, and the other one was good. So we replaced out those guys. Let's put this thing back together and see what we get. Now earlier in the video, you got to see me put it back together, so I want y'all to take a break while I do this off camera. Okay, we'll see you in a little bit after I've got it all back together. Here's our variac. I'll tell you what, that variac, that's a handy tool to have. There's not a day goes by that I don't think I don't use the variac. I use it all the time. Here's our other trusty workhorse. Voltage doubler. Let's plug the variac. Plug the voltage doubler into the variac. Let's bring our bus wires out. Side here. We're not done. Okay, we're not plugged in yet. We're going to set this up so we can watch. See where our DC voltage is. Push that a little bit back. A little tangled. Plug our meter to bus ground. And bus plus. Just keep those separated. Let's scoot a little bit so I can get the mirror in here. Mirror looking at the LEDs. Here's bus ground from the voltage doubler. 1, 2, 3, 4. And here's bus plus from the voltage doubler. 1, 2, 3, 4, 5. closer up glasses here and double check that. You don't want to hook this up wrong. All that nice work we did would go up in a puff of smoke or a bang of fire. 1, 2, 3, 4 is bus ground. That's good. 1, 2, 3, 4, 5 is bus plus. That's good. Turn our meter on. Plug the variac in. We have so far 77 volts DC. Okay, we're going to go up slowly. Somewhere around 170 volts, this thing should switch on. Doggone it. I'm about to give up on this. That should have come on by now. We're at 262 volts DC. Okay, we're going back in. So we got a good UC 3843. We saw it work. We replaced the 470 ohm resistor. We replaced two 120 kilo ohm resistors. Something else is still bad. All right, we'll let that DC bus discharge, and then we'll go back into it and keep on looking until we get it going. Starting to get frustrating though, isn't it? It comes with the job. Now we're going to pull this MOSFET off right here. And we'll test it out of the circuit. And once again, the leads are bent over. They can't make stuff easy, can they? With this MOSFET out of the circuit, we'll check those 120 kilo ohm resistors again. It's that MOSFET that I am not sure what it's doing in the circuit. We're all loosened up. See if we can straighten those leads out so it'll pull right down. Okay. We'll set that aside for now. Let's check those 120 kilo ohm resistors. because I think we should be able to measure 120 kilo ohms and not 88 or 90. We in the circuit. Okay, with the MOSFET removed, what do we have? The same. The same. Let's take a look at the Zener diode. Let's go ahead and pull that Zener because that's pretty low value for a Zener diode, 0.392. Let's take that Zener diode out of the circuit. Before we do that, let me get a picture of it so I can get it oriented back in. Don't want to put it in backwards. It's loose. It is loose. We have the MOSFET and the Zener removed. Let's go ahead and measure them. See how they measure out of the circuit. Hold still now. Yeah, that Zener's been zinged. That Zener should be up close to 0.7, but we've only got 0.4. 0.4 diode drop. Let's check this MOSFET. Okay, I can turn that MOSFET on and off, and it appears to be good. So what happens? You put your black lead on the drain. This is for N-channel MOSFET. Put your black lead on the drain. Come on, hands, start working. Put your red lead on the gate. And then you can take your red lead from the gate and put it on the source. And you can see we're turned on. We have 0.005 volt diode drop. Now remove the black lead from the drain, leave the red lead on the source and touch the black lead to the gate, and that will turn it off. There we have a 0.499 volt diode drop between drain and source now. Okay, red lead on the gate, black lead on the drain, red lead to the source, black lead on the drain, 0.005. Black lead on the gate, red lead on the source, black lead on the drain, red lead on the source, 0.499. We were able to turn that MOSFET on and off. That's a good MOSFET. We can keep that one, but we got to do something about this Zener diode. I need to look at the part with a loop. If I can see it. What do we have? Let's check our 120K resistors with that MOSFET and Zener diode removed. Wow, look at that. 120K, 119.6K. Now, I have a new Zener diode. It's part number BZX85C15. Here's the old one, and here's the new one. We're going to check the new one. Oh, let me get in diode test mode. Look at that, 0.700 volt diode drop. That's what a Zener diode should measure like. Let's go look at the bad one again. 0.401 volt diode drop. That Zener diode has been zinged. Now, there's a new MOSFET. I'm worried about, even though we tested that old MOSFET good, I want to put a new one in there because this circuit is just befuddling me and I want to be done with it. Let's check this one, just like we checked the last one, and see what we get. 0.005. 0.502. 0.005. 0.502. Okay, we're going to use that new one. We're going to put all new parts into this circuit eventually by the time we get done. Okay, diode first. Set that off to the side there. Just a little bit more. Okay. Cathode to the right. Okay, got to spread it out a little bit more. Bent it too close to the body of the diode. That should do it. Yep, there we go. For the MOSFET. That should be good. Good right there. loosen the board up and we'll put it back together and see what happens. Let's see what our 120 k ohm resistors measure like with good parts installed. Oh, there we go. 122.6 kilo ohms, not 88. 120.5 kilo ohms, not 88. So that will be a clue for the future. If we measure those two resistors as not 120 kilo ohms, then take a look at this MOSFET and Zener diode. Okay, let's put it back together. Okay, let's see how we did this time. Powered up the variac that's connected to the voltage doubler. We have 70 volts DC right here at this moment in time. We gradually increase the DC voltage. Look at that. There's an LED. So close to giving up. There's 300, 316, 320, 321 volts DC, 322 volts DC. I'll zoom in on the camera. You'll see that LED. Look at that. One LED. But that's enough to tell us that we are working. We fixed another one. Good job, folks. That was a grizzly bear. Let's see what our voltages are. We should have 5 volts on the logic. Let me bring this around to that side. Turn the light on. Let me find a logic IC. I think 5 volts, 15 volts maybe. Yes, there's 16.96 volts on a CMOS IC. Over here's an operational amplifier. Get on ground. There's 17.1 volts DC. Let's go to the other side. And there's 17.3 negative volts, negative 17.31 volts on that operational amplifier. We're good. We are good. Whew. Let's power down. Nice work. How close was I to giving up? I was just a skoshie bit away from giving up on this thing. Nice job, folks. Nice job. Pat yourself on the back for not giving up. Okay. Hope y'all's doing okay out there. We'll see you in the next one.